So we have just a few more areas to cover before this rig can be passed to an animator. And one of the more important is the foot. We could leave it as it is. We can move the controls around and the foot will follow, but it's a bit basic and doesn't give the animator a lot to work with. So in this video we are going to add more functionality so poses are more easily achievable. Let's look at the FK controls first, as these are quite easy to set up. With these controls we only want them to be visible when animating in FK. But don't worry, once we're finished setting the foot up, they will automatically hide themselves. What we want to do first is make them follow the FK foot control. To do this, we simply parent them to it. Nothing complicated about that. So we just move these to here. Because we cleaned these controls earlier, and by that I mean move the values down to the offset parent matrix section in the attribute editor, we now have values here because the controls parent has changed. So this is a new offset. So what we need to do is remove these new values. First we need to reset the offset parent matrix section. So right click and go to Set Matrix to Identity. Let's do that on the big toe too. Now let's check where they are in world space. So reset these values. And now let's move them out of the hierarchy. And reset the values again. Okay, good. They are at the world origin, which means they don't have an offset baked into them. This could have been done using the Freeze Transformations tool. Now we have checked that, we can parent the toes back to the foot control, and now match the first control to the joint it's going to drive. So select the first big toe control, and then the first big toe joint, and use the Match Transformations tool to snap the control to the joint. Now do the same with the little toe, snapping it to the little toe joint. We can now reset or clean the values again. So move them down here or use the script. Okay, I'll just make sure the other controls are still aligned. Yep, good. So we need to make sure we are working with the FK skeleton too. So hide the IK thigh joint and make sure the FK thigh is visible. We don't want to control the wrong joints. What we need to do now is clean the FK joints so we can connect the controls to them directly. So go through and move the values down. Also remember to reset the joint orient values too to correct any movement. I'll go through and update the other toes now. Okay, that's better. Now open the connection editor. Disable non-keyable. And bring the big toe controls into the left side. And the joints into the right side. And simply connect the translate and rotate attributes. We can move the joints now with the controls. Let's do the same with the little toe. Just connecting those translate and rotate attributes to the joints. Okay, so that's the FK foot controls in, connected and working. And if we switch to IK, they vanish. Perfect. Told you it was quite a simple setup. Okay, let's look at setting up the IK foot now. And this is a little bit more complicated. Let's hide the FK joints and bring back the IK ones. What we're going to do with this version of the foot rig is add in a simple foot roll control. This will take the foot's pose from being back on its heel up onto the ball of the foot and then over onto the toes. So the animator only needs to adjust one attribute to achieve all three poses, quickly and easily. This is ideal when working on walk or run cycles. We will also add in the ability for the foot to bank from side to side too. If you want to see a more comprehensive foot rig setup, check out this video over on my YouTube channel. So to create the foot roll, we simply need a joint chain which will drive the main foot, and this is known as a reverse foot. Let's start by duplicating the main foot joint, as that's in the ankle position already. Delete the children. I'm going to rotate this so it's more in line with the toes, which will make the movement more predictable and exact. Okay, let's move it out of the hierarchy, so it's just sat inside the leg group. We want this joint to be on the floor, so set translate Y to 0, which will bring it back down. And move this back. This will be where the heel will pivot from. So here looks good, but we can adjust it later if needed, once things are up and running and we can see how the foot is rotating. Let's rename this to foot left reverse heel. And delete that constraint node too. Duplicate this and move it forwards. This will be where the foot pivots when the creature is standing on its toes, so put it between the end of the claws. And change its name from heel to toe, and parent it to the heel joint. Duplicate the toe joint and move it back. This time it needs to be in line with the first toe joint here. So as the foot rolls forward, it bends on the toes. Call this one ball. Create another copy and parent it to the ball joint. Call this ankle. We want this one to be back where the ankle joint is, although we need to keep it aligned with the rest of the reverse foot. Okay, let's match the ankle's position first. Just the position, not the rotation. I'm going to use the reroute tool now, which will essentially flip the joint's hierarchy, so the ankle joint is now at the top. This will allow me to adjust the rest of the foot joints to align them with the ankle. Switch to the top view for a second, and isolate the joints. And now we can adjust the rotation to line them up. It's important these are all aligned or the foot won't roll correctly. Okay, that's better. We can swap the hierarchy back now using the reroute tool again. We need the hierarchy this way around so the joints rotate in a specific order. So the heel moves the whole foot like this. The toe then lifts the ball and the ankle, and the ball moves the ankle. So you can start to see how we are going to get the foot to roll. We are going to be connecting directly to the rotation attributes. So let's go through and clean the joints, just to simplify things. Remember to also update the joint orient attributes too. Okay, good. Let's quickly remove the colour too. Just set it to default for now. Parent the heel joint to the foot control. So the joints will follow where the foot goes. With the IK leg, we included the toes so we could control them in IK too. We now need an additional joint, and this will help to keep the foot level as the control moves. This wouldn't be needed on a standard biped rig, which has just one toe. But we have two toes, so this will control the ankle for us too. Duplicate the foot joint again and delete its children. Now match the new joint's position to the reverse foot's ball joint. Just use translation for now. Now parent it back to the IK foot joint. And rename it to ball left IK. That's the main control joints created, so now we need some empty groups. Press Ctrl and G to create a group. Rename it to inner left bank group. Duplicate this and change the name to outer left bank group. These will be used to pivot the foot as it banks from side to side. Match both of these to the heel joint, so we get the same orientation as the reverse foot. Now move these so the inner bank group is on the inside of the foot, and the outer bank group is on the outside. Next, parent them to the foot IK control. So here we have the two groups. Now parent the outer bank group to the inner bank group. Again, we need to control the rotations directly, so we need to clean the values. There we go. So the foot will pivot something like this. Now parent the reverse heel joint to the outer bank group. So you see, the groups will move the foot like this and this. Let's hide the reverse foot for now and switch to wireframe so we can see the joints. We are now going to use a series of IK handles to control the foot and toes. So, open the IK handle tool options. First, if you remember, we connected the foot IK joint to the control using an orient constraint, so we could animate and pose the foot. We're going to change the way this works now, so let's find and delete that constraint node. Here it is. Create a single chain solver from the foot IK joint down to the new ball IK joint. You see, we can use this now to control the foot's orientation. And it will work better with the IK limb. Now create 4 more IK handles spanning each section of the toes. So we have 5 in total. Let's quickly rename these to match the joints they are driving. OK. Now parent them to the foot IK control, so we can move the foot as before. But if we move the control down, you see the foot and toes follow, as if the foot has peeled from the floor. So it's a much more natural movement. Let's bring back the reverse foot. We have the main driver IK handle here, which was a key part of the quadruped limb. It's currently parented to the foot control, but we need it to instead follow the reverse foot. So, as the ankle lifts, the rest of the leg will follow, and the knees will bend. Quickly parent it to the reverse foot ankle joint. Now parent the first 2 IK handles to the reverse foot ball joint. And finally move the other IK handles so they are parented to the reverse toe joint. So they are all moving with the reverse foot now. And we can pose it so it's on its toes. Actually, let's move these so they are parented to the toe joint too. OK, that looks better. Now move the ball IK handle so it's parented to the reverse ball joint. OK, those are all set up now, so it's time to start working on the main controls. First we need some extra attributes. On the foot IK control, create a new controls divider. and then add two new float attributes, foot roll and foot bank. So this is all we need for now to get the foot moving. Traditionally, you would use set-driven keys to set up a reverse foot system like this. They are simply animation curves which allow you to manipulate one attribute with another. The problem is I find them to be quite limiting. Plus, they aren't very economical. So instead, we are going to set ours up using nodes. Now these can come across as being more complicated, but they are so much more flexible. Open the node editor and bring in the foot IK control. Let's look at the foot roll first. Bring the reverse ball into the node editor and open it up. At the start of your foot, beginning to peel off the ground, your heel rises so you are standing on the ball of your foot. Something like this. So we need to do this first. It looks like we need the rotate X attribute. So let's connect the foot roll attribute directly to it. So we now have the first stage of the foot roll. Now things start to get a little bit more complicated. As the foot moves onto its toes, like this, the ball then needs to flatten back out again. Like this. So we need a way to reverse the direction it rotates once it gets past a certain point. We want the rotation to rise to a point, but then go back down even though the foot roll attribute is still climbing. Let's look at the point where we want the foot to start moving onto its toes. So around 25. Remember that number, 25. Create a new condition node. We have used these briefly before, so you should be familiar with how they work. Call this foot left roll condition. First we need to check when the foot roll attribute goes above 25. So change operation to greater than and set second term to 25, the value we want the foot to rise onto the toes, and the foot ball joint to stop bending forwards and start bending backwards. To recap, if the first term goes above the second term value of 25, the condition node outputs the colour if true value here. If it stays below it, it uses the colour if false value instead. So it's a good way to quickly compare things. Let's connect the foot roll attribute now. Connect this to the first term attribute. We also need to connect it to the colour if false R attribute too. So if first term is less than 25, roll the ball forwards. Now set colour if true R to 25. So basically what will happen is if the foot roll goes above 25, the ball joint will stop moving and be locked at 25, which is the colour if true value. Now connect out colour R to the joint's rotate X attribute. Let's test that. So now the ball doesn't go past 25, even though the foot roll attribute has. Okay, so we have control over the ball now, so instead of being locked at 25, let's make it reverse and move backwards. Create a plus minus average node and call it foot left roll reverse PMA. Connect foot roll to input 1D0 and also input 1D1. This now gives us two inputs here. Now delete the first connection, which will leave us with the attribute. Now set input 1D0 to 25, the point where the ball starts to reverse. Change the operation to subtract, so we are taking 25 away from the foot roll value. Next we need another plus minus average node, so duplicate this one. And let's call this subtract instead of reverse. So the first node will give us an opposite value to work with, and this one will take it away for us. Connect output 1 from the reverse plus minus average node to input 1D1 on the subtract plus minus average node. Let's go back to the attribute editor. This time set operation to sum. So what we're going to do is replace the 25 in the colour if true section here with the new value, which will reverse the direction of the ball. This is coming from the two plus minus average nodes we just created. Connect output 1D to the colour if true R attribute. OK, let's have a look. I'll reset this to 0. So we move up to 25. And once past it, fingers crossed. Yep, the ball reverses. Perfect. OK, good. Now let's add in the toe movement, and we can use some of the nodes we already have. So what we want it to do is lift the rest of the foot. Add the reverse toe joint to the node editor, and create a multiply divide node. Open it and call it foot left roll tip multi. Connect the output 1D attribute from the reverse plus minus average node to the input 1x attribute on the multiply divide node. Now connect output x to the colour if true G attribute on the foot roll condition node. We can use the same node because we still want to check if the foot roll attribute goes above 25. So here, if it's greater than 25, it uses this value here. Let's connect out colour G now, so it's the same column, to the reverse toe joint. Rotate X again, just like the ball. We also need to change colour if false G to 0, so the toe joint's rotation will be 0 while the foot roll attribute is below 25. If we try that now, you see the toe joint is moving, but it's the wrong way. So all we need to do is change the input 2x value in the multiply divide node to -1 instead of 1. That's better. The foot moves onto the ball and then up onto the toes, all using a single attribute. OK, so now we need to work in the opposite way, so the foot can roll back onto its heel. Don't worry though, this is a bit simpler. Let's remove these and bring in the reverse heel joint. We need another condition node so we can check when the foot roll attribute goes backwards, so into negative figures. Call it foot left heel condition. This time we are checking to see when the first term is less than the second term, so change operation to less than. And connect foot roll to first term. So this will tell us when the foot roll attribute goes under 0. If it does, use the foot roll value. So connect that to colour if true R. If it's not less than 0, use the colour if false R attribute instead. So set that to 0 so the heel joint doesn't move. Now connect out colour R to the heel joint's rotate X attribute. OK, so now as we increase the foot roll value, the foot moves onto the ball and the toes. If we reverse it, it goes onto the heel. Although it looks like the heel pivot is too close to the foot, so let's move that back to a better position. I'm just going to press insert so we don't affect the rest of the hierarchy. Let's try here. OK, that looks better. I might play around with it a little bit more later. I've spotted another issue though. As the foot rolls backwards onto the heel, the ball joint continues to roll back too, which we don't want. So we need a way to clamp that. Let's reset the foot. Select the ball joint and graphics connections. I'll just open these. So we need another condition node which will tell the ball to stop rotating if the foot roll attribute goes under 0. And we can put this between the main condition node and the ball joint. We will call this one clamp. Connect outColor R from the foot left roll condition node to the first term attribute on the clamp condition node. Let's check the attribute editor. OK, reset these. So set this to 0 and operation to less than, because we are checking for when it goes back onto the heel. OK, now connect outColor R again from the roll condition node to colour if false R, and we will leave colour if true R set to 0. So if the foot roll is below 0, the ball joint stays at 0. Now connect outColor R from the clamp condition node to the rotate X attribute on the reverse ball joint. OK, give it another try now. Perfect, works like a charm. So that's the foot roll set up now. So let's look at the foot bank. And this is easier, so don't worry. All we essentially need to do is tell these groups to start rotating depending on where the foot bank attribute is. If it's a positive number, bank one way. If it's negative, bank the opposite way. So we can use a condition node again to set this up. Bring the two bank groups into the node editor. And the foot IK control. Create a new condition node and call it foot left bank condition. Let's open this. We know we want the foot bank attribute to be the main driver, so connect that to first term. Let's move to the attribute editor now. Change operation to greater than so we can check when the first term value goes above the second term. So this way we can check if it's a positive number. If it is, we can use colour if true R here. So let's connect foot bank to that. And set colour if false R to 0. So this group doesn't move if the first term is less than 0. What we can do is set up the opposite action on the next column here. So if first term is less than 0, we can use the colour if false G value here instead to drive the other group. Connect foot roll to colour if false G. And this time leave colour if true G set to 0. OK, let's check what axis we are using. Looks like Z. So connect outColor R to the outer bank group's rotate Z attribute. And outColor G goes to the inner bank's rotate Z attribute. I may have these the wrong way around, so let's check. Ah yes, just as I thought. OK, let's just swap these over. That's better. We now have a foot which will rock and bank, plus roll forwards and back onto its heel. Now what I usually like to do is have another control in front here controlling these two options, which is more interactive for the animator. With this, it's the translation values that drive those first term attributes rather than the foot roll and foot bank attributes. I plan to have a full demonstration of this on my YouTube channel at some point in the future. So look, we can also move and pose the foot. And the controls still work, and stay relative to the foot control's position and orientation. OK, I realise this video is getting a bit on the long side, but bear with me, we just have one more step to go, but it will add so much more flexibility to the rig. First we need some more attributes, so create 3 new float attributes called heel twist, toe twist, and toe tap. Now open the connection editor. The foot IK control automatically loads into the left side for us. Let's look at the reverse heel and see which attribute will twist it. Rotate Y. OK. Load the heel joint into the right side of the connection editor. And all we are going to do is connect the heel twist attribute to the heel joint's rotate Y attribute. As easy as that. OK, let's check the toe joint. Looks like we need rotate Y too, so the toe twists. Load the reverse toe into the connection editor and connect toe twist to rotate Y. So now we can pivot the foot from the toe and also from the heel. The toe tap takes a little bit more work to set up. This time we need to control the IK handles so they move up and down, rotating the toes. First, clean the values on the two end IK handles so we have 0 transforms. Now connect toe tap to the Translate Z attributes. This will make them move up and down. Now if you wanted to, you could set this up so you had 2 attributes, one for each toe. Or maybe include one so the toes can spread too, so move side to side. Once you have the main reverse foot set up, you can add as many extra finishing touches as you like. OK, so there we have the foot rigged. Now there is something I just spotted, which I thought I would mention before we move on, just in case this happens to you. You may find that as you blend between IK and FK, the toes flip, like this. Now don't worry, this is just the constraint. All you need to do is select the main joint with the constraint on, the one the model is skinned to, and change the interpolation type to shortest. You see, the toes snap back. Let's update the other joints too. OK, that's much better. And it was just an easy update, but I can see how something like this could stress you out and have you pulling your hair out wondering what is going on. OK, that's the foot done. We just now need to repeat the process to do it on the opposite side. And what I'll do is I will work on that between now and the next video. Speaking of which, in the next video we will look at the last 2 areas we need to rig, and that's the clavicles and the finger controls.